we would have no problem, or I shouldn't say we, but ultimately there would be no problem clutching each of these. So you could literally physically break these pieces. And going back to the automotive arena, if your motors knew that this was upright and so on, you could use a mechanical disc brake. They will stop upwards of 12,000 pounds of physical torsion.
Okay, it'd take a heavy person to fall on it.
Yeah.
Okay.
But a mechanical discs are cable driven. It would be one linear actuator, could break every single operating apparatus for all rows.
Okay, and by break you mean stop.
Every single one of these would have to have a disc and have a brake on it. But it would be easily obtainable parts.
Right.
They're cable driven. You know, if you wanted a redundancy, you could say, okay, for every 2 rows or whatnot, there's another set, but I don't think you'd even have to prove that.
Right.
And one linear actuator could supply the force to break all of that apparatus, and all the seats would stay within the limit of their play. Mm-hmm. That's as far as they could go when you were loading and unloading. And those were just some of the base ideas that I had out of playing with it and trying to overcome some of the obstacles. Because I looked at some of the things like you'd be utilizing pillow blocks and, you know, and various ball joints and all of these different things. But then what I tried to do is dumb down a lot of the usable apparatus to parts that you could find inexpensively.
Right.
You know, and that's where the idea of using, you know, the disc brake or using, you know, automobile CVs or so on.
How are you supporting your main rods then, your drives? The long rods that are actually doing the actual.
That would be it would be pillow blocks galore. Okay. Yeah. It would be pretty crazy. And then when I looked at it too, an interesting thing too is this tube diameter, as you've already stated, I believe, for 1 seat or 2 seats might work at 2 inches, but it may have to be upwards of 3 to 4 to drive 4 to 5. Mm-hmm. Or it may have to become something that's square that then goes to a round rider that's then in a pillow block.
Right.
Just for the sake of being able to say, okay, and then
this can
withstand that.
Same thing about bringing a round drag rod through the pillow blocks. And then he says it'd cost you a fortune to have that rod broached for one thing, and then have your actuating arms fit to them. They'd have to be specially made. Well, we'd have to make them anyway. He says,
yeah.
But he told me, he said, a square rod will still fit in a pillow block. Mm-hmm. And it's a lot cheaper. Then all you have to do is make your arms and punch them out for a square. And slide them down the rod.
Mm-hmm. Will you have greater wear though on the square? Is it the 4 points?
No, he said no. He says no.
Okay.
Because it's still riding in the bearing.
Okay.
I wanted the same thing. He said no.
We've done it before with our stuff, and the square rod will, depending on the grade of the steel, will actually wear more.
What?
And honestly, that comes out of lack of maintenance. Because if your pillow block is moving properly, then you would not get anywhere at all. But the day that one of them stops moving properly, then it becomes metal on metal.
Sure.
But you would hear that, I would certainly hope.
Right.
A great way around that, though, is, and it's more involved, but with skilled welders and so on, it's not a huge issue, is you can just as easily make the square portions round if you have someone that's skilled enough. You know, I don't know that I would recommend that on a job this scale. Mm-hmm. Of this particular scale. But, yeah, we've physically done it in our facility where we've added material and then just machined each section and sent it through areas, you know. But I'm in agreement, regardless of how you're running through a pillow block, I think square stock is where we're going to land on a lot of things, because it makes everything line up immediately. Meaning, okay, we need plates to go from here to here for the linkage, and they're all going to be the same length. They're all going to be the same size. They're all going to have a half-inch hole on one side and a 1-inch, square on the other side for the square stock. And then when it's physically being assembled, because you have to think of not outside of everything else, you have to think of how is this physically going to go together. And then it's a matter of marking all these intersections and sliding the plates to that point, and everything gets tacked together.
Outside the room, and then take the assembly kind of, at least the rod with all the pillow blocks.
Maybe even in the room, and your everything's tacked together, you can physically see things move and say, okay, our measurements work.
Okay.
And then you can start doing final welding, and so on. Because that's
Well, my thought is, if your room, your walls are here and here, you're not gonna pull this the whole way out. Unless this thing is in multiple parts, and I think we want one solid rod. But we're probably getting ahead of ourselves.
Another great thing where square stock is indispensable because square stock is easily keyed.
Gotcha.
So a 1-inch square stock can have a 5/8 inner, 3/4 outer, depending on the actual size of your steel. And that's something I wanted to represent here, which is you could have all of these sub platforms ready, and then the only change that you make is these universals just represent where you've keyed two pieces to come together.
Okay.
So you could make all these pieces, have things tacked in place, bring them in, and then just slide all of your keyways together.
Nice.
Adjust width, various things like that. You're going to have variations in your floor, other things like that. Maybe your Legos or your stock will start to twist like our Legos here. But then all that is correctable at that point, because let's say you've got your keyways to land together, but this pillow block is a 1/2 inch too low. Well, thankfully you've only tacked it in place in the assembly here, so you're actually going to space it on site, and then you're going to final weld. And that's something you learned in the automotive arena real fast. You cut a floor right out of a van and replace it with something else, it's never the same twice. Never, ever. You know that just from pulling exterior steel off. It's never the same. So what you do is you start by just putting it in place, verify everything, and then you go from there. And that's a construction aspect of things.